This is the 2014 Tables, Relationships, Graphs and Equations paper. Question 1, investigating number patterns, number of layers of cans, and this is the number of cans in the layer. So in the first layer there are 4 cans. In the second layer we've got 1, 2, 3, 4, 5 cans. In the third layer we've got 6. The fourth layer we've got 7. So to help us work out this one, we need a pattern. Obviously it's linear, it's going up in steps of 1. So we're multiplying by 1 and clearly adding 3. 3 more cans than the layer number that they're in, so the number of cans in layer 7 would be 7 plus 3 is 10 cans. Right, so plotting this data on the graph. Now we need to think about the sort of data it is. It's clearly discrete, and that means whole numbers. So we're going to be needing to use crosses rather than a line. In the first layer, layer 1, we've got 4. The second layer is 5, 6, 7. It doesn't say where to stop, so we'll keep going. Need to consider 0th layer, but obviously 0th layer won't have any cans, and we don't need to join it up. Right, part 3. Equation for the number of cans A in any layer. So we'll start with a table. So layer 1, and A is going to be the number of cans in that layer. So I can see it's going to be 4 times 3, which is 12. And in layer 2, 1, 2, 3, 4, 5, we're going to have 5 and 3 rows of that. 15. Will be 6 times 3 is 18. 4 is 7 times 3 is 21. So clearly, once we've added 3 onto the layer number, n plus 3, we're going to multiply that by 3 to get the number of cans in layer A. You might want to show off expanding that. 3n plus 9 would be the other way to work it out. Right, the display is 15 layers high. It also has 4 cans in each row of the top layer. How many cans would she need for the bottom layer of this display if each layer is made of 3 rows? So if we remember from the previous page, layer and the number of cans. Layer 1, remember, had 4 times 3. Number 2 had 5 times 3. N had n plus 3 times 3. How many cans would she need for the bottom layer? So that would be layer number 15. The 4 cans in each row tells us it's exactly the same as the previous question, so the same formula will apply. 15 plus 3 times 3, so we need to show some working. You must show use of your equation. So the equation was A equals 3n plus 9 if we use the factorised expanded form. So A will equal 3 times 15, we want layer 15, plus 9. That would be 54 cans. Right, we're asked to sketch a graph. There's the equation. Every equation, every graph has a table. I can see we're going from -5 to 5. We could also have a go at putting it into the calculator and a table. This emulator here on the computer is quite old now, but will be similar. Right, we're going to need brackets around that top line. And now I've lost my emulator. So we'll put in x squared plus 7 times x. And we want to divide that by 2. Oh, and we just lost it there, so we'll put it in again. Right, this time now we can set it. We want to go from, let's try from about -7 up to 7 in steps of 1. Right, so we can have a go at plotting this. -7, it was just as well we went to there because that was 0. You can have a look on your table if you like. Then what have I got? -6 is -3. And I'm getting these numbers from the calculator. We're starting to see the symmetry. And then I think it's 9. Right. This is just a maths graph, so it will be continuous, which means I can join it up with a line. It's clearly quadratic, which means it should have a parabola. Parabolas have a pointed bottom, not a flat one, so it's got to come around the bottom there. Back up. Try and just do one line, it's a bit hard on the screen. And definitely go past the last point. We could put an arrow on the end, and same with this one to show that we understand it goes on forever. Right, so there's my maths graph. Equation for the total number of cans tea in a display with n single row layers. So n equals the layer again. How would the graph of the relationship between t and n differ from the graph you drew in B1? Well, once we start talking about a practical graph, we need to start thinking about the difference between that and the maths graph we've just drawn. Obviously, if n is the layer, then n is going to start greater than or equal to 1. And also, if n is the layer, then n is discrete, which means whole numbers. So we wouldn't use a line. They would be discrete points, and we would start with the point 1, 4.